Hi. Okay, today we are going to learn continuity of a function. You learned that last time, and then we also go over IVT, which stands for
Intermediate value theorem.
Intermediate value theorem. Thank you very much. Okay, Noah, you are fabulous. So, started from what we learned last time. See if you can remember. If a function is continuous, what must be true? If f of x is a continuous function at x equals to c at this point, okay, three condition has to be true. Yes?
Like if you plug C into X, it has to be a point.
Yeah, it has to be a existing point. So substitute f for c into f. This point has to exist, right? Cannot be undefined. Very good. What is the second part? Has to be true.
The limit of f of C has to be consistent.
Also, the limit has to exist as well when x approaches c of the function also exist. And how can a limit exist when x approaches c?
When it equals f of
All right, can I give somebody else a chance? Thank you very much, but anybody else? We just have a quiz on limits, right? When is limit exist?
When the right hand limit equals the left hand limit.
Yeah, when the left hand limit equals to the right hand limit. When you meet somebody for lunch, you go to the same place, not a different place, right? Then the limit exists. You meet each other. What about the third one? Somebody from this side. Yes, this two, 1 and 2, has to be the same value. The value of f of c needs to be equal to the limit, the same height. All right? So when you are justifying why the function is continuous at a certain point, these are the things you have to show me. Yeah? Now, I would like you to sketch a graph for each scenario. We have different type of continuity. Removable, that means it's an easy fix by a single point. I can either put in a point that was not there before, right, undefined as a whole, or I can adjust the value of that point to make it continuous. So those are called removable. Can you sketch each situation on your OneNote? What is a jump?
Like a piecewise function?
And what is the infinite discontinuity? So sketch a graph first. And who want to come up to sketch the first two? Anybody? Sebastian, you're the closest. You want to try? Yeah.
Can I do just one?
Sure. Excellent. Like the arrow on both sides. Anybody else? Rachel, you're also very close. Easy to get out. And you sketch anyone of your choice. You, Andrea. And next, Derek, you're sitting in the front. Oh. Excellent. So now, I don't know what your graph look like, but can you use those three conditions to tell me each graph, which one does not, oh, these two are actually the same. Isn't it the same? So, I'm going to remove that point. And these are different, right? So, 1, 2, 3, which condition failed from the first removable discontinuity? Let's see. F of C exists, right? Let us see. Yeah, F of C does exist. Does the limit exist?
Yes.
Yeah, limit exists. They approach to the same value. The problem is number 3, right? Failed number 3. The limit is not equal to the value of the point. Good, so number 3 failed. All right, the second one, which one does not apply? Does F of C exist? No, so it's already disconnect. Yeah, okay, right there. So F of C does not exist. Therefore, it's impossible for the 3 to be true. If I want to define what is a jump discontinuity, okay, we can use this to justify, right? Any jump discontinuity will be like the left-hand limit is not equal to the right-hand limit. So number 2, it doesn't matter if the value exists or not. If the left-hand limit not equals to, doesn't agree with the right-hand limit, then it belongs to a jump discontinuity. All right, the last one, infinite discontinuity. That means when x approaches to C, there is a vertical asymptote. This is one of the example. What Rachel graphed, what is the possible function equation for that? What is it, Jake? What is this graph? You forgot. Who can help Jake? Alvin. What function is this? What function is this? 1 over x, right? Rational function. And what's happening at x equal to 0? What kind of asymptote? Vertical asymptote. And what is the behavior of the graph near the vertical asymptote? Because you're hitting the wall, right? You don't want to hit the wall. Where can you go? You can either go up to avoid to hit the wall, or you can go down to the negative infinity, right? So when the function, the limit near the vertical asymptote, either go up or go down, we say there is an infinite discontinuity. It doesn't need to be both sides. So if just one of the sides, the limit when x approaches C from the left, or the limit when x approaches C from the right, either of the side, when the limit equals to positive or negative infinity, then we say there is an infinite discontinuity. Because the graph could look like this, maybe only one side. Wow. Only one side goes up, and maybe the other side is linear. Doesn't matter, right? You have one side goes to infinity, so we will say that's an infinite discontinuity. All right, understand what the continuous function is about. Kind of set us up for the intermediate value theorem. Okay, so before we do that, let's see if we can answer this question. So take a look. This is a piecewise function. Which one is not true? You can discuss with your neighbors. Go through each answer.
A is not true. X equals to 1.
Okay, first question I have for you. What is the domain for this f of x? According to this piecewise function.
From 0 to 2?
From 0 to 2, is it inclusive
No,
or not?
not
Not inclusive because no equal sign, yes. Every point within this interval, open. Okay, let's look at number one, A. F of 1 does not exist. Is it true? Not true, I see some heads shaking. If it's not true, that means you tell me it exists, right? And what is f of 1 then? Is 1. It tells us when x equal to 1, y is 1. F of 1 is 1. So this is true. Okay, oh, it's not true. Okay, B, when x approach to 0 from the right, the limit of f of x exists. Limit approach 0 from the right. That means I'm going to sub in here, right? What is the limit? Does it exist? Does it exist? Yeah, it does, right? The endpoint is not there. There is a discontinuity, but the limit does exist. And this is a polynomial, it's a linear, so we can just find the limit by sub in. So what is the limit approaching from right of 0? What is it? You guys are tough audience. Come on, give me some answer. What is it? 0. Yes, 0 times 2 times 0 is 0. So that is true. Limit approach, limit of f when x approaches 2 from the left. 2 from the left is between 1 and 2, so I'm going to sub into this. And I can sub it in because it's just linear. It does exist, right? And what is the limit? Negative 2 plus 3. The limit is 1, correct? Now this is also true. The limit when x approaches to 1 exists. Well, this one we need to work a little bit. So first of all, we don't care about is f of 1 exists, right? It doesn't matter. We just want to see if you meet somebody for lunch, are you gonna see each other? Doesn't matter if the restaurant is there or not. So from the left side, from the right side, do you approach to the same value? So we need to sub in x equals to 1 on either side. So left side will be this, right side will be that. So the left hand side limit is 0. The right hand side limit, sub into the bottom one. Oh, it's not 0. What am I talking about? It's 2. You're right. What about the right hand limit?
Also.
Also 2? Yes. So the limit exists. Is that true? Very true. Yeah. Last one, the limit is equal to f of 1 when x approaches to 1. True or false?
False.
It's false because by comparing the limit and the value, they don't agree. So this is false. Did you choose A and E? Both of them are not true. Let your head if you choose those two, or one of those two. Great. All right, next two question. Pause the video. Okay, so the bottom question. Can you, which of the following points of discontinuity is not removable? Is not removable. We know that the removable discontinuity means it's just a hole, right? If it's a hole, then it's removable. I can just patch it in. So can we find all the holes? For the rational function, any factor I can cancel, there is a hole at that point. So which point has a hole? The one I cancel. X equal to what? 0. Oops. Yeah, x equal to 1 also has a hole. This one? Okay, I'm gonna keep it for now because, yeah, there is a hole there. There's a hole there. Equals to 2. But then, because I only cancel one of them, so the numerator.
There's also an x intercept there.
Right, I need to keep that. This one totally cancel, right? So there's a hole at -1. This is 2 and a 3, so I have 1 here. So after simplifying everything, this is my simplified version of the function. That means f is going to look like this. And what does the graph look like? Rational function, right? It's going to look like rational function. Who can tell me the vertical asymptote of this function? Where is it? X equals to 3. Denominator equal to 0. All right. Ha ha ha. Horizontal asymptote? How do you find it? Is there a horizontal asymptote? Rachel?
1.
Where is it? Okay, we don't say 1. 1 is just a number. Y equals to 1. Come on, no baby talk, you guys. Y equals to 1 is the line. So horizontal, so you take the leading term and divide. So x minus 2, yeah, looks like they also has a hole there. So many holes there, but which one is not removable? That's the, remember what I said? Wherever there is a vertical asymptote, it belongs to the infinite discontinuity, and it's not just a quick fix of patch a hole. So this answer should be B. All right. All right. Next. Last time we also mentioned this, but that's after the quiz. Everybody is really sleepy. I want to re-emphasize. If you have a closed interval that the domain is from A to B, any point within the domain, right, inside domain, not including the endpoint. For inside, any point to be continuous at that point, we already know 3 conditions, right? F of C needs to be equal to the limit. So if that's true, every interior point within the domain will be continuous. How do we make sure the endpoint is also continuous? Well, since the endpoint, the graph only have one side, right? If it's the left endpoint, there's no graph on the left side. So when we check the limit, it's only checking the one side limit. So look at point A. I only need to check the limit from the right. If that equals to f of A, then that point is continuous. Versus the right side, B is the right endpoint. So do you check the limit approach from left or right? There, left. There's nothing on the right. So check the limit from the left, make sure that's equal to the value of B, and that will exist. All right, so the example here, I'm just gonna quickly go through this. My function f is a radical function, square root of 3 minus x. Where is my 0? Can you sketch the graph? Find 0 for me. David? What is 0 of f?
Square root of 3.
Square root of 3. That is the y-intercept, right? When x equal to 0, that's y-intercept, square root of 3. Where is 0? That is when this is 0, right? What is x? 3. So 3 minus x is 0. That is how you find the 0. Okay, David already give it away. I was gonna ask you, does the graph go to the left or go to the right? Since I have a point here, it's gonna be this, right? What is the domain? Yeah. What is the domain, guys? For any radical function, the easiest way to find the domain is set inside greater or equal to 0, right? Because you cannot put negative number inside the root, so the domain should be less or equal to 3. So here, less or equal to 3. So when you check the endpoint, is it continuous? We need to check one side limit, and which side would you check? Approach from the left or approach from the right? Well, that's why the domain is helpful, and also the graph is helpful. I only have the right hand limit, so I need to check the limit approach from the left of 3 and make sure that is equal to f of 3. Checking that, and you can tell me, yes, f of x is continuous within this domain. Yeah. Cool. Did we do this question last time? You have the notes from page 6. I am not sure. Did we? No.
No, we have our version, but not your version.
We did this on the whiteboard.
We did this on the whiteboard?
Yeah.
So I'm gonna skip this, okay? We have more questions. So, continuous function, can you find a value of a so that the function f will be continuous? Piecewise function, the only one single point we need to check is which point? Matthew? X value, which point we need to check? X equal to -1, because what type of function are they? The two p's? Look at the power. It's quadratic, and quadratic is part of the polynomial family, right? Any function in the polynomial family, they are superior. They are continuous or real number. And that is a given knowledge. Everybody know. If I give you a polynomial function, you can say it's continuous because it's polynomial. So the only problem is that connection. When they connect, do they connect at the same point or different point? So, and remember the 3 conditions we have to check, right? Justified, what is the value of A if f is continuous? So, number 1, we need to find what is f of A, f of 1, -1, sorry. F of -1, sub in top or bottom? Bottom. Equal sign is at the bottom, so I'm gonna sub in here. So, -1 squared is 1. Okay, so that's in terms of A, right? I'm trying to find what A is supposed to be. Not any A value will make them, continuous. Number 2, check the limit from the left hand side and the right hand side. So the limit has to exist. So left hand limit, use the proper notation. Approach to -1 from the left. Look at the domain. From the left, supposed to be the top. X is less than -1. I'm gonna sub in -1 here. This one. So the right hand limit is 3. Right hand limit is sub in the bottom is gonna be the same, right? This is a minus 1. In order for the limit to exist, right? 3 needs to be equal to a minus 1. So what is a? A needs to be 4. Okay? So when a is 4, then the limit x approach to -1 of f should be equal to f of -1, which is equal to 3, right? Yes. So you check it by, see if the statement will be true. A lot of problem for the AP Calculus AB student is communication skills. For the AP exam, you need to justify using theorems, using definitions. So see how much work I have to do to answer that. A lot of students just do this. Just sub in both and say 3 is a minus 1, so 8 is 4. This is all you give me. I don't know what to explain, how to explain. Do you want me to put all this concept in myself? That is me asking me, okay, Miss A, can you see it? Well, I can't. If I can't see it, that means you're not explaining using the definition. Is that clear? You have to show me this. All right. Definition of a continuous function has to have 3 parts, all true. All right. This one is a little bit tricky. I'm gonna come back to it. Because it might take too much time. I want to introduce today's star. The topic, star of the day, is IVT. And what does that stand for? Say it. Intermediate value theorem. What is intermediate value? Is it X value or Y value? What is that supposed to mean? All right, I want to give you an example. It's so easy to understand. So basically, we're telling you this is the input value X in your function, right? Is f of X. This is the output value, Y value. I'm going to give you a scenario that X is somebody's age in years. Y is somebody's height as you centimeter. Okay? Let me see. Let me choose one. Choose one person. Okay. I'm going to choose Jacqueline. Jacqueline, how tall are you? 160? Yes. And how old are you? Give me just a round 16 years old. Okay, so when Jacqueline is 16-year-old, she is 160 centimeters. Jacqueline, when you are 10 years old, can you just give me a random number? 120. Okay, she was 120 centimeters. She grew up. And now she is 160. So what is the intermediate value theorem? F is a continuous function, right? When she grew from 120 to 160, it's continuous. Don't you think? she is going to pass every single height between 120 and 160 to get to 160. It's not gonna skip a value, is it? So that's why it is so important that in order to use the intermediate value theorem, f need to be continuous. Otherwise, you cannot use this theorem. So every, when you go from 120 to 160, yes, this is 10, this is 16, is continuous. 10-year-old, 16-year-old. So, intermediate value theorem says, I am guarantee you that at the age between, right, at the age between 10 to 16, I'm gonna choose a height, 130. This is my value. I can find a time, an age, C, where her height will be 130. Is that easy? Because 130 is between these two values. There's a maximum value, there's a minimum value. You have to go through 130. So what does that mean? I can guarantee I can find a value C where f of C is equal to 130. Is that understandable? Can I guarantee that there is a certain age that her height is 100? No, because that's too low, right? I can only guarantee any number in between 120 and 160. Can IVT guarantee that there is a certain point between age 10 to 16 that she was 170? No way, because that's not within this two value. So intermediate value theorem is talking about in between the y value, minimum value and maximum value. Okay? Yes, sure. So now, when we understand the context, let's look at the intermediate value theorem. When we're talking about intermediate value, it means the value that's in between two y values. Because the nature of the continuous function, right? You have a point A, this is the x. Sorry, can you cross out that B and put B here? It's placed. This is a closed interval. The x domain is from A to B. Okay, and I can find the endpoint of this interval. This is f of A, right here. And when I substitute B into function f, I can find the value of f of B. So this is the y value, f of A and f of B. And this is a continuous function. Okay? So let's look at the definition of the theorem. If f is continuous, very important, you have to say that first. On the closed interval, AB bracket, K is any number between f of A and f of B. So K is actually the y value. We're talking about the y value, right? K is between f of A and f of B. Then there is at least one number, C. C now is talking about x value, right? Her age between 10 to 16 years old. I can find a value C here that's satisfied. If you draw the line here, when f of x equals to k, I can find the value C that satisfy what? F of C is equal to k. Okay, so we can find at least one number of C in the interval AB such that F of C is equal to k. So it takes a while for you to try to justify in this way. And then what is the key component? Number one, you have to address the continuous function. All right, maybe on the closed interval AB, usually it's within the interval, because why? We need to find the endpoint. What is the high value and low value? So we can put the value in between. So number three, we need to find the y value, f of A, and f of B. And number four, you can use IVT. IVT can guarantee what? There will be a value C. Guarantee that any value k between is not necessarily f of b is always bigger. It could be f of a, but right now I'm just gonna assume f of b is bigger. F of a, why do I do that? It's between f of b and f of a. If k is between these two values, IVT guarantee that there will be at least a value C, and then C is in AB, yeah? Such where f of C is equal to k. So that is your justification. IVT can only guarantee a C value within this domain satisfy f of C is equal to k. And k is between the f of A and f. If you forget, just think about the height of Jacqueline. You will get it. Yes. Sure. All right, next. Understand the meaning of IVT. Can you see which one is correct? So it will help if you can define the domain, the x value, and you can define the y value. Right? So what is the x value? And what is the y value? Okay, who has the answer? Which one is true? A? Let's look at A. It says IVT guarantee that f of c equals to 4. At least one c within -2 and 1. So yes, this is the x value, right? So the interval is between -2 and 1. C has to be in here. we have the endpoint, right? 3 and a 6. Okay, so that means you are going to find value between 3 and 6. And 4 is in between, yes? So that is correct. So IVT guarantee that you can find a value C within the domain, -2 and 1, satisfy that FOC equals to 4. Why? Because 4 is in between these two numbers. Yeah. Okay. Are we good? Let's do this question. Consider the function of x, which is x squared plus 2x minus 2, and x is within -1 to 3, which is a closed interval. Explain how you know that there is a value c that satisfies the equation f of c equals to 3 in this domain. Okay, I'm going to start. First, what do I need to address? Remember the number 1? You know? What do I need to address before I can use IVT? Say it again? Continuous, yeah. F has to be continuous. And look at the function. Which family is this function? Family? Quadratic is a polynomial. So, I'm going to say, since f of x is polynomial, is a, you can write quadratic, but polynomial function, so it's continuous. On the interval, right, or real number. So including that interval, -1, 2, 3. So checked. I said it's continuous. Now I can continue to find the next. Second, I need to see what is the endpoint, right? I have the interval -1 to 3. So I'm gonna find what is f of -1. We know that the value of that is -3. The other end, f of 3 is what is that? 15 minus 2, 13. Look at the question. What would they want to make us say IVT guarantee? The value 3, right? 3 is 3 in between -3 and 13. Yes, we can guarantee that. Because the continuous, in order for you to go from -3 to 13, you have to pass the value of 3. So, since 3 is between -3 and 13, 3, big number here, small number here, and I like to state that this is between f of 3 and f of -1. Then, by applying the IVT theorem, okay, we guarantee, right, or let me write that, there must exist or must be a value, a number C in this interval. What interval? By the way, here you can use close or open. It's fine. C must be in here, that where f of C is equal to 3. Finished. is the thorough way to justify why IVT guarantee this will be true. Okay? So now, next question, I want you to work in pairs on the board and write the proper, okay, let you write this down so you have a reference to go to. The next question, I'm gonna skip this and go here. Let's look at the question first. Does f of x, which is x cubed minus x minus 1, have any roots on this interval? First of all, let's define root. When we find the root of a function is finding x-intercept, finding zeros. I'm asking you, is there a 0 in this interval 1 to 2? We know the cubic function, right? If your x-axis depends on where your function is at. If my 1 to 2 is here, is the 0 within 1 to 2? No, it's not. Is there a 0 between 1 to 2? Still no, right? So if this is the case, is there a 0 between 1 to 2? Yes. So what do you need to check? You need to check this interval, the endpoint. You see this is a positive value, negative value. If you want to go from positive to negative, don't you need to cross the 0? Or vice versa, if I go from negative to positive, don't I need to cross that? So that is your scenario here. Okay, so go ahead, go to the board, and write a beautiful solution for this. Basically, you're going to use IVT to say, yes, we guarantee there is a root there, or no.